and talk about what it looks like in terms of a table, in terms of like an equation, a function, and in terms of a graph. So you're going to see it all three ways. We're going to do 3 examples of all 3 methods. You won't have homework tonight because it is, again, this is something that's kind of a repetition or a repeated concept from the last unit test. What I do want to remind you, though, is that when we're talking about a table, there are 2 ways that a table can be given to you. You can be given a table vertically. This would be called a vertical table, where your left side of the table is considered to be your x values. The right side of your table is considered to be your y values. Or you can be given a table horizontally. A horizontal table has the x values on the top written there, and the y values would be written underneath. Okay, so you need to understand the placement of your x terms and your y terms. Now, with constant of proportionality, you have something that's called a k factor, or a k value. And that value of k can be found by taking the y, your term of y, and dividing it by your value of x. And again, it does not matter which value of y you use, as long as you use the corresponding x value with it. They have to align. Okay? As an equation, when we put it in equation form, it would be written as y equals k times x. Y is equal to k times x. That's what it would look like as an equation, where y and x are going to be your variable terms, meaning they are going to stay written as y and written as x. They won't actually be any kind of number. The only one that's actually a number is going to be the k. K will be a physical number. So it might be something like y equals 7x, y equals 2.5x, y equals -4/3 x. Shh. Okay, that's the setup for an equation. So let's go ahead and first take a look at some tables of information here. So I'm going to give you a horizontal table here, where we're going to be displaying how hours relate to miles. So maybe we're talking about a speed or a road trip that we're taking. So over the course of 2 hours, a car travels 120 miles. Over the course of 5 hours, the car traveled a total of 300 miles. Over the course of 9 hours, it traveled 540 miles. So we're just displaying information about the distance that a car is traveling over the course of hours. And we want to know, based off of this information that's been given, what is the constant of proportionality? Or essentially, what is the k factor? So again, when you're given this kind of information, let me zoom in so it's a little easier to see. When you're given this kind of information, you have to identify which set of values represents your x and which set of values are going to represent your y. Which set represents the x and which set represents the y. So which one of these is the x, the hours or the miles? Hours. Remember, we just talked about it here. When given a horizontal table, your x data is going to be written on the top, your y data is going to be written on the bottom. So hours is going to represent our x terms. The miles is going to represent the y terms. So when I'm trying to set up my value for k, again, k can be found by taking your y over your x. You're taking the y over the x. It does not matter which y you use and which x you use as long as they pair up. So, for example, if I do 120, I can't do 5. It has to be 120 and 2. Or it has to be 300 and 5. Or 540 and 9. You can't mix and match. They have to correspond with each other. Okay? So I'm going to show it to you for all of them. If I do 120, it's going to be over 2. If I do 300, it's going to be over 5. If I do 540, it's going to be over 9. And because this is a proportional relationship, they're all going to be equal to the same value. Say it louder, Gabriella. 60. It's going to all be equal to 60. Okay, they all come out to the exact same value of 60. So that means K, in this case, is going to be equal to 60, but I don't want to leave it just as a number. You always want to relate it back to the context of the problem. So it's 60 what? 60 over 1, yeah. But it's 60 miles, right? That's what Y was. Y represents miles for 1 hour. So I'm going to write that down. It's 60 miles for 1 hour. That's what our constant of proportionality is. 60 miles for 1 hour. Now, if I wanted to write this as an equation, again, if we reference back up here, this is how the equation gets written. Y is equal to kx, where k is just a number. Y and x stay as y and x. So when I'm writing it out, it's going to be y is equal to 60x. That would be the equation. Okay, let's try another one. We've got minutes and the price. Okay, so for a course of 10 minutes, maybe we're paying $150. For the course of 35 minutes, we're paying a cost of $525. For the course of 50 minutes, we're paying a price of $750. So again, this is a horizontal table. Which of these values, minutes or cost, is going to represent the X? Minutes. Okay? X is going to be the minutes. The cost is the Y. X is going to be the minutes. The cost is going to be Y. So when we're setting it up, we're going to set it up as Y over X. So I can set this up as 150 over 10. I could do 525 over 35. I could do 750 over 50. Michael, focus. Okay, all of these are going to come out to the same value. What's 150 over 10 going to equal? 15. They all are going to come out to 15. 525 over 35 comes out to 15. 750 over 50 also comes out to 15. They're all going to come out to the same exact value. So that's what our K value is. K is going to be equal to 15, or 15 over 1. Now let's relate it back to the context. Remember, the top is your Y, the bottom is your X. So 15 is 15 what? $15 for one what? minute. Okay, always relate this stuff back in context to the problem. So this is going to be $15 for 1 minute. $15 for 1 minute. Who wants to tell me what the equation would be? If I write it as an equation, what am I going to write out? Go ahead, Gabriella. Y equals what? 15x. Okay, y equals 15x. That's what the equation would be. All right, I'm going to give you guys a table to try on your own. You're going to identify what the k value is. You're going to put it in context to the problem, and then you're going to write the equation. So it's 3 things you're doing. Tell me the k, give it to me in context, write the equation. All right, Nick, why don't you tell me what is the k factor? Yeah, 180. Very good. So when we set this up, again, we're going to set it up as y over x. X is going to be representing our hours. The calories burned is going to represent the y. So we can set this up as 540 over 3. We can set it up as 1,260 over 7. We can set this up as 2,340 over 13. Each of these is going to simplify down to 180. They all simplify to 180. So we know that k is equal to 180, or 180 over 1. Now relate it back to the context. Relate it back to the problem where we're talking about hours and calories burned. How would I write that out, Tony? Huh? Okay, so that's our equation. Yeah, that's our equation. But we want to relate it back to the context here. Kind of like how we said, okay, $15 for 1 minute. Denim. Very good. 180 calories burned for 1 hour. Okay, so that's how we would relate it back. 180 calories burned for 1 hour, or in 1 hour. Okay, that's the context of the problem. And then just as Tony had already said, he said the equation is going to be y is equal to 180x. So it's very simple material. I think the part that people have the most difficult time is putting it in context. That's probably the most difficult that people struggle with. That's the concept that they struggle with the most, is putting it back in context of the problem. Okay? The second mistake that people make is they look at these tables and they automatically want to go 10 over 150 or 3 over 540 because they see the table set up that way. But you have to remember it's always the y over the x. Okay? So if you can just remember how to set up your table, then it makes it a little bit easier. Let's go ahead and go to page 86, the next page. We're going to talk about the equation format. So that was the table format. When given a table, identify the factor and then how it relates, the context. But if I give you an equation, can you identify the factor and how it relates in the context. So these are pretty simple as well. I'm sorry that they are a little bit lengthy in writing, but this is exactly what you're going to see when it comes to testing. You're going to see it in word problem format, but these problems are the easiest. When they're giving you the equation, it's the easiest questions to answer. Okay, so Neil is practicing for his typing test. The equation y equals 45x represents the total number of words y. So the total number of words y that he can type in X minutes. So 45x, y equals 45x, represents the total number of words y that he can type in X minutes. We want to know what is the constant of proportionality. Okay, so constant of proportionality, again, is that k value, that y over x value. When it's already given to you as an equation, it's the easiest thing to identify. What's our k? 45. It's the easiest thing. When they want to know what is the constant of proportionality, that is your k value. So when they're talking about y is equal to k times x, your constant of proportionality is that k. That's what we're looking for. So 45 is the answer. That's it. K is equal to 45. Now, relating it back to context, the context, it's 45 words typed in 1 minute. Because it's technically 45 over 1, right? So it's 45 words typed in 1 minute. So that's what we're going to write down. 45 words typed in 1 minute. There's our answer. All right, get those two problems written down and work those out. Remember to identify what is the k value and then what is it when it relates back to the context of the problem. All right, who can tell me what is the k value for problem number 5? What is that going to be? Mia, what is the k value? 55. Good. So our k value is going to be equal to 55. Okay, that's the easy part. Now relating it in the correct context. Okay, so relating it with the correct context. What is that going to be? Angela. 55 miles in 1 hour. Okay, so 55 miles traveled, right? It's how far they're going to travel. It's not their speed itself, it's just how far they're traveling in 1 hour. Okay, for problem number 6. Problem number 6, what is that k value? Darren? 125. So we get that 125 again. That's what it is based off of the placement in the equation. Now let's relate it back to the situation here. How's it going to relate? I need to try somebody who hasn't answered it. Javen, you haven't answered in a while. I'm surprised you don't. 125 calories in a cookie. Good. So 125 calories per cookie. Okay, 125 calories per cookie. Okay, the last way that we are going to be identifying our constant of proportionality is in graph form. So when we are identifying the constant of proportionality, the very first thing that we are going to do is we are going to pick a perfect point. By perfect point, I mean the line crosses through a point that is exact. Okay, the line crosses through an exact point, meaning that I can tell, hey, the x is exactly this number, the y is exactly that number. And to keep in mind, your x value is what's written first. It's the horizontal line. It's what goes left and right. Your y value is that vertical line. It's what goes up and down. That's your vertical axis. So when we're talking about a point, we put them in order in coordinate grid systems as x, comma, y. That's the first thing that you're going to do. The second thing that you're going to do is identify the k value from that ordered pair that you picked. And remember, your k value is set up as whatever your y value is over the corresponding x value. So you pick a point, and even though the point is written as x, comma, y, when you're identifying your k, you identify it as y over x. Now for proportionality, proportionality does not have to be written as a unit rate. It just has to be written in its simplest form. It just has to be written in the simplest form. So sometimes you might get a fraction that is not over 1, or a value that is not over 1, and that is okay. You still need to know how to also relate it back to the graph or the information that's being given, the context that's being given. So let's start with problem 1. Did you have a question?
No.
Okay. So let's relate it back to question 7. In here, the first thing that we want to do is pick a point. We're going to pick a point on the grid. It does not matter which point I pick because of the fact that this is a proportional relationship. How do I know again that this is a proportional relationship? Denim? It goes through the origin and it's a straight line. So I know all of these graphs that I've been given are proportional. So they are going to have a constant of proportionality. It doesn't matter which point that I choose. Okay, I can choose one of the points that they gave to me, or I can even choose a point on my own. So in fact, I'm going to go ahead and choose a point on my own. The point I'm going to choose is located right here. I'm going to choose this point. And this point starts at the 4 for my x value and goes to the y value of 20. So right below here, I'm going to go ahead and write that this is my x. 4 is going to be my x. Okay? And 20 is going to be my y. So when I write this as an ordered pair, it's written as 4, 20. 4, 20. That's my ordered pair. Now I'm going to identify. So I've identified a point, right? I picked a point. I picked the point 420. Now I'm going to go ahead and write it as a value of k. And k can be written as y over x. So that means I'm going to write this as 20 over 4. 20 over 4 can simplify. It can simplify to 5 over 1. Okay, so that means that if I relate this back in context to the problem, it's 5 what? Is it 5 minutes per 1 gallon? Is it 5 gallons per 1 minute? It's 5 gallons per 1 minute. That's correct. Because again, Y represented the gallons. This was my Y. Y represented the gallons. X, these were my X's. X represented the time. So when I write it in context, the top number represents the Y. The bottom number represents the X. This is going to be 5 gallons of water used in 1 minute. Five gallons of water used in 1 minute. As an equation, it's going to be Y is equal to 5x. Y is equal to 5x. Okay, let's take a look at problem number 2. Again, I'm just going to pick a perfect point. Can somebody tell me a perfect point along this line? Look at yours. Find a perfect point on the line. Perfect point, that means I can identify what the X and the Y values are because it crosses over these grids perfectly. Raise your hand if you've got a point. Aiden. You mean 4 and 6. Remember, we do X first, Y second. So 4 and 6, that's perfect. Good. We're going to go at 4, 6. Okay, now remember, the 4 represents your X value. That 6 is going to represent your Y value. When we set it up, okay, our X is a 4. Our Y is going to be the 6. We're going to set it up as 6 over 4. Notice 6 over 4 is not going to simplify to a whole number, is it? It's not going to simplify to a whole number. In fact, it simplifies to 3 over 2. That is okay. That's our K factor. Our K value is 3 over 2. In context to the problem. Go ahead, Gabriella. $3 for 2 magnets. Good. It's the cost is $3 per 2 magnets. That's what it is. That's your constant of proportionality. It's $3 for 2 magnets. Okay, if we write this as an equation, it's going to be Y is equal to 3 halves. Y is equal to 3 halves X. Okay, very quickly, because we're about to leave, I'm going to do the last one. Okay, for the last one, I'm going to pick the point located right here, where X is equal to 1 and Y is equal to 6. X is going to be equal to the 1. Y is going to be equal to 6. So when I write this as an ordered pair, I write it as 1 comma 6. When I set it up as my K value, I'm going to set it up as 6 over 1. 6 over 1. That is as simplified as it's going to get. In context to the problem, it's going to be 6 feet per 1 minute. 6 feet per 1 minute. And in context to the problem, the equation is going to be Y is equal to 6x. You do not have homework tonight. We will review on Monday for the test.